Hi, and welcome to this short preview of some updates to Polygonica's remeshing algorithms that are coming in release 2.4. As always, please note that Polygonica can only be licensed as software libraries. The demonstration programs I'm using in this video aren't for sale. The current remeshing algorithms in Polygonica are focused on providing better quality triangles. What we mean by quality here is an aspect ratio that's closer to equilateral. The idea is that long, thin triangles are replaced with shorter, fatter triangles. Having a more even spread of triangles across a part is useful for a variety of purposes, ranging from performing mesh modifications such as smoothing, fairing, and morphing, through to things like mesh analysis, where it's convenient to represent some numerical value per vertex, and ideally that would be spread evenly across the surfaces of the part, not just where vertices happen to have been placed by a CAD system. Common examples would be to compute and display wall thickness for additive manufacturing, or stress values in finite element analysis results. So in this demo, I'm just going to show you remeshing on two small parts. If we look at this bracket part, it's largely prismatic. It's got lots of planar surfaces and lots of sharp edges. And if I highlight out of aspect ratio triangles, we can see there's lots of them. I'm sorry about the color scheme, but I guess it does make the point. So if we look at the remeshing controls, there's quite a number, and I'll talk about some more of them later. But in the first instance, we're just going to do a uniform remesh based on a target edge length of 0.005. I guess this part's defined in meters. And we've got keep sharp features turned on, so we're going to preserve those hard edges or feature edges. Okay, so Polygonica's taken about 5 seconds to do that on my 4-year-old Dell laptop. You can see we've got a very nice uniform remesh across the surfaces here, and everything looks really pretty good. The number of polygons has gone up from around 3,000 to around 60,000. And obviously Polygonica's remeshing can be used both to increase polygon density, triangle density, across an entire part or across a region of a part, and it can also be used to decrease it as well. So although we also offer simplification decimation algorithms to do that, but it's very flexible. And we can also see that all these triangles now fall within the aspect ratio threshold. So the long thin triangles have gone and we've got an even spread of short fat triangles. So now we'll keep the edge length the same. Let me reset the part, important to remember to do that, and click curvature sensitive remeshing. So in this case, Polygonica is going to add more triangles with shorter edge lengths in areas with higher curvature, and larger triangles with longer edge lengths in areas with lesser curvature or planar areas, planar regions. So if I click that, so that's completed in 6.7 seconds, and now you can see we have a nice graded variation of larger triangles in the planar areas through to smaller triangles where they're required by the curvature. We look at the back side here and we look at this hinge. We've got a very nice result across the hinge, and again on this plane, flat planar surface, everything's looking really good. In this case, the number of triangles has gone up from 3,000 to 41,000, so slightly fewer than in the fixed edge length case or uniform remeshing case. But we also have another control, and maybe more sensible control, for curvature sensitive remeshing, which is the maximum error. So this is a tolerance such that the resultant part after remeshing will always lie within that distance of the original part. So I'm going to set that one to 0.001. So it means, again, sorry about the small numbers here. And let me reset that. Okay, and remesh. Okay, and so that took a similar sort of time, 6.8 seconds. I chose the tolerance to be similar to the average edge length from the previous example, and we've got a similar number of triangles, 45,000 as opposed to 41,000. So it's a roughly similar result, but I mean, it's just giving you an idea that you've got these different controls. Okay, so I'll close that part, and let's load up a slightly bigger part. So here we have, again, apologies for the coloring, it's already highlighting the out of aspect ratio edges. If I just show you the edges, and let's just turn that off for a second. So here we have a sort of a kind of topology optimized type bracket with 134,000 polygons, which represents a 6.5 megabyte binary STL file. And I'm just going to run through pretty much the same process I did with the previous part. So let's use a uniform remeshing with an edge length of 1 unit, which is I'll get that going, which is slightly rough for this size of part, but I don't want it to take too long in this demo. Okay, so that's taken 12 seconds, and again you can see we have a really nice result. If I look at the holes in the base here, yeah, you can see that these are a bit rough, and really we needed a slightly tighter edge length to preserve that. But I guess it really depends what it is you're trying to do. But as you can see, there's a nice uniform remeshing across this complex part. Okay, let me reset that. And this time do curvature sensitive remeshing, but with the same edge length, or same target edge length. Okay, so that's taken a little bit longer, 16, 17 seconds. But again, you can see we've got a nice curvature based result here, where we've got larger triangles in the regions with less curvature and more triangles in the regions with a lot of curvature. So yeah, again, another pretty nice result there. Okay, let me reset that, and this time go for a maximum error of 0.1. So this part is 171 by 62 by 105, and I'm using a tolerance of 0.1, and let's get that going. So I forgot to say that the previous result, I think, dropped the triangle count slightly from, so I think it was originally 130 and it dropped down to about 100,000. And again, I've tried to pick a maximum error that gives a similar result to the target edge length, and in this case the number of faces has dropped to 82,000. And you can see the result looks pretty similar. In this case it took 20 seconds. We've got a similar sort of edge length around these holes here, etc. So yeah. Okay, so that's a really quick overview of some of the new remeshing that's coming in 2.4. Please note also, remeshing can be controlled using a target triangle budget. So in this demo we call it faces number. So you can specify a desired number of faces, and Polygonica internally will convert that in effect to an edge length. And also this preserve boundaries option allows you to, if you want, you can keep the vertices on the boundaries of open edges preserved so that they don't get changed, and it really depends on your use case whether you want that or not. And finally, the max edge length option, that prevents triangles in the curvature sensitive situation from getting too big. So obviously if you had a huge flat plane, you could get very, very large triangles, which you may not want. You may want to restrict it and keep an even spread of smaller triangles across the planar area. And so that's what this max edge length parameter is for. So thank you very much. If you've any questions, as ever, please don't hesitate to contact us. There's forms on www.polygonica.com. Thank you for your time.